Okay. Hello, everyone, and welcome to practice set 4. So, as usual, today we're going to be going all over the exercises. I'll try to pass over all of them. If there's anything you want me to focus on while I'm doing this, please let me know. And just a note, if you haven't already checked recitation 5, make sure you do that because over there I go heavily over cardinality. So I did it. So our last recitation was number 4. I did one offline. It was 5. So with 4 we went over functions, sets. In recitation 5, I focused on cardinality. I did it offline so you could have time to watch it before, because we didn't have time to go over it in recitation 4, and it was important for this practice set. And this week, I think you've already seen we're going to be starting new ideas that have to do with induction. So recitation 6 is going to be based on that, inductions. And I don't think we're going to have a lot of time to go over past ideas before your next exam. So cardinality functions, I'll try, but I'm not sure if I'll have time for it. So recitation 6, we're going to be starting a new idea. Make sure you revise every old idea in case you find that you have a weakness somewhere. I'll try to if I said anything significant in recitation 5, I'll try to repeat it here today. Okay, starting with part 1. Use set builder notation to represent the following. So in other words, just how can we actually write a set? So for the first one, 0, 3, 6, 9, 12. It's the multiples of 3, but not all of them. So 3n such that n belongs to the set of natural numbers and n is less than 4. So first of all, you're saying it's going to be the multiples of 3, but then you add a condition that actually this isn't enough. Okay, so first of all, you're just saying it's 3 times something, and that something is a natural number, and it's less than 4. Note that this is the correct thing, but note that it's different than saying this. If you said 3n belongs to the natural numbers, such that, so you can write such that as 2 columns or backslash, whatever. N belongs to, or n is less than or equal to 4. If you said this is different. What are you saying? 3 times n, the whole thing belongs to the natural numbers. And you're saying, hey, n is less than or equal to 4. So this isn't the same thing, because now I can say, hey, I can set n to equal, let's say, 1 over 3. 3 times 1 over 3 is going to be 1. So 3n is going to be 1. It belongs to n. So that's fine. I satisfied this condition. And hey, 1 over 3 is less than 4. So I satisfied both conditions. So you have to be careful with how you set your notations. So n belongs to the natural numbers, not 3n. The rest are pretty easy. X belongs to the z integers, and the absolute value of x is less than or equal to 3. So, or you can say, hey, x is between minus 3 and 3. That's also fine. Kind of like how they did it with part C. So C is a letter, and C is between M and P. So then it's M, N, O, P. Like in alphabetical order, it goes after each other. So like A is less than B, till you reach D. Exercise 2. So, let A, B, C be sets. We want to either prove or disprove the following statements. First one, A cross brackets B union C can we do like the distribution? Can we say now A cross B union B cross C? It's not exactly distribution, but is this equivalent? Well, makes sense. It should be equivalent, right? Because what are we saying? The set A will take, so A cross any other set is just going to be a couple, let's say XY or AB, whatever you want. So the set S, it's either, if it's the union of B and C, so all the elements of B and C, is it the same as saying, hey, first cross A with B, and then those elements, you union them with A cross C? It should be the same. Let's see the proof. So starting from the left-hand side, A cross B union C, it's XY such that X is in A and Y is in B union C. Okay, what does this mean? It just means either Y is in B or Y is in C. Distributive law, the actual distributive law of propositions. So X is in A and Y is in B, or X is in A, Y in C. But you can break this down into two different sets now. So the first one, X in A, Y in B, union the other set, So it's A cross B union A cross C. So yeah, they're equivalent, and it makes sense. What about the other one? So A minus B intersection with C minus B. Well, it's enough to just say one of them minus, right? You don't need both of them. It's kind of here like you're intersecting A with B, and sorry, A with C, you're intersecting them. And then you want to remove the elements of B. So if you remove the elements of B here or here, it should be enough. Is it the same as A minus B union C? A minus B union C? Well, obviously not, right? Because here we're saying, hey, intersect them and then remove B. Here we're saying, hey, remove all of B and all of C from A. So it's not the same. I think easiest way is just to take a counterexample. So you can check this on your own. Just any counterexample that makes this not work. Part C, A minus B minus C. Is it the same as A minus the union of B and C? It should be. So first remove from A the elements of B, and then from that remove from what the set that remains, remove the elements of C. Or right away just remove from A all the elements in both B and U. Similarly, like part A, you keep going through definitions. I think someone may have asked me, should we be writing the rules next to the questions? I'm not sure what exercise you were talking about, but if it was this one, yeah, kind of like when we were doing inference rules, just write the step and then write the reason. Okay. I won't go through the details, but I think it looks fine, right? Yeah. Again, the steps here are very clear. You can just go over them on your own, and if you have a problem, let me know. Okay. Just the first step. So X belongs to A minus B as a set minus C. So first of all, you break down this minus. You say, okay, A is X is in the first set, which is A minus B, and it's not in the other set, which is C. Then you break down this one, and you keep going. So kind of like if this was in how we did it with implication, if it was like this, first you do this implication and then this one. Or it might not be that different if you go either way. D, for any set X, prove that X bar bar is just X. So the double complement of x is the same. There you go. So x, that x is in the set x. Add double negation doesn't mean anything. Insert the first negation. So it's now x is not in x. But that means that the element is in the complement. Enter the second negation. X is not, there's a bar here. X is not in X bar. Do it again, the double complement. Part E, using XOR, or symmetric difference, in other words. Well, if you didn't know already, symmetric difference is associative. So all you had to do here was just move the brackets. After moving the brackets, when you have X is in B, symmetric difference, or XOR, with X is in B, this is always going to be false. Because what is this saying? This is only going to be true in this case. If the first is true and the second is false, or vice versa, or the other way around. But both sets are, or both propositions, statements are the same. X is in B, X is in B. It's either going to be this or this. But using XOR, this is false, so we just write false. Now this statement, x belongs to A, XOR with false, it's just going to be x is in A. Why? Well, again, either x is in A, this is either going to be true or it's going to be false, right? Well, when you're XORing it with false, you don't care about this step because it's going to be false. So yeah, exactly. Or 1 with 0, that might be something that's true. So it's left x is in A. Part F is going to be like part A and part C and part D. You just have to go through the steps. But now there's sort of like an implication. So you start with this. Instead of before we had equal, you want to have equivalence. Now you have an implication. So you're going to see like, hey, the steps are going to be implies, 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 not equivalence. Okay, start with the first step. A union B is subset in A intersection B. What does that mean? If there's an element in A union B, then this is a different application than this one. If there's an element in A union B, then that element is going to be in the intersection. Same as your exam, or same as the first part of this course, this is a simple implication, alpha, beta. Do not alpha or beta. Keep going till you reach what you want to reach. The last step was, hey, A is subset in B, and B is subset in A. Internet went off. Sorry about that. Share my screen, please. Um, is my screen, can anybody see my screen? Share content. Yeah, that's probably because it's not there. I'm trying to fix that. Um, okay, the screen won't share for some reason. I'm gonna end the meeting and start again. So please rejoin. Sorry about that.